Hello, everybody. Good morning. I'm Mike Tango Bravo from OpenVino, and this is our submission for the Aleph Verano hackathon. Thank you all for making this happen. We've really had a great time. OpenVino does tokenization, transparency, and traceability for the wine world. So in tokenization, we enable wineries to generate their fungible ERC20 tokens backed by bottles of wine that can be bought and sold on OpenVino Exchange, which is our ViniSwap DEX. Transparency is where we enable wineries to self-certify their production. Certifications like organic, provenance, carbon footprint. So the types of artifacts, the types of proof that wineries can provide could be images, which we're storing on IPFS. It could be work logs, what happens in the vineyard and the winery, analytics such as chemical analysis of wines, IoT sensors from the vineyard, from the winery, documents. And so that's why we're here. So what are the real problems we're solving in this hackathon? 3 things. Demonstrate that they're actually a winery, and that the wine that they want to tokenize and certify on OpenVino actually exists. The second thing is to give them an immutable platform to store data, for example, work logs and sensor data. And the third and most interesting is give them the capacity to prove that they're in compliance with a particular certification, for example, organic, without revealing information that they consider confidential. So in this scenario, we have a winery, Bob's Winery, and Bob is going to connect to the INV. This is the government regulatory agency in Argentina for wine. And Bob is going to send to the INV clear text with a chemical analysis of his wine. In the third step, Bob is going to connect to OpenVino, and he's going to write the same data, the same information that he provided to the INV, but in this case, we're going to use fully homomorphic encryption such that those items about his chemical analysis that he doesn't want to share with the world are hidden. And he's also going to provide sensor data on chain. In the fourth step, OpenVino is going to compare the hash that INV has written to zkSync with the hash generated from Bob's connection through FHE and make sure that they're the same. Basically, what we're doing here is we're validating, we're saying you gave information to the National Wine Board. We don't know exactly what it is because some of it's encrypted, but we know that the information you're sharing with us is the same. And we know that you're actually a legitimate winery because you were able to authenticate with them and that the wine exists. And by doing the check on the FHE data, we can say, well, I don't know what the information is, but you are or you are not in compliance with organic requirements based on thresholds from the information you provided. And finally, after we've gone through this process and issued a BioDigital Cert and say, yes, this is an organic wine, Alice can now see the certificate and also can see some of the data, for example, sensor data that Bob has published on zkSync. What we're building in the hackathon is we've built the gateway that takes IoT sensor data from actual sensors that are in a vineyard today in Mendoza and write those to a zkSync gateway. The second step, we've written the zkSync to OpenVino Exchange to be able to graphically display this and validation. And the third step, we've built the connector between the winery, the INV, and OpenVino so we can validate this hash using zero knowledge proof. And in the fourth step, the winery is sharing information with OpenVino, encrypted with FHE, with Zama FHE. Our FHE computation is very lightweight. We're only doing it one time per wine, and it's numerical, so it's not actually that compute intensive. Right now, for the hackathon, we're writing, of course, to zkSync era on Sepolio, but we want to do this on our own custom chain, our OpenVino chain, and every winery will also be an OpenVino chain node, and we'll use DApp node to deploy that. And finally, we'll do a periodic Merkle tree hash to mainnet. That's where we are. We're ready to actually deploy this in a real-world environment. We signed an agreement with the National Wine Board to develop these types of things. So let's have a quick demo and take a look at this. Now Bob is going to connect to our mock INV site, and he's going to register a bottle of wine and present the different results from his chemical analysis. And in this case, we're using things like trace elements like lead and copper and arsenic, things that might show up on an analysis, but he doesn't necessarily want to share with the public. The INV is going to write a hash on zkSync, and now Bob is going to BioDigital on OpenVino, and he's going to present the same information. In this case, however, he has the option to select which of these data points should be encrypted using FHE. So again, he was writing in the clear to INV. INV generates a hash and writes to zkSync. In this case, he's sending the same information to OpenVino, but this information is encrypted. And after a check, we should see that the values that he sent us come up and showing that this wine is in fact organic. And the last step is simply that we compare the hash from the INV of zkSync with the hash that we have generated. We think we're ready to go. The market is ready. We're our first mover, so help us make it happen. Thank you all.